Okay, so good morning from Cape Verde and welcome to our presentation. So we are Angelic, Lotus, and we are presenting on a hybrid deep learning model, CNN and GRU for crop yield prediction under climate impact, a case study of India's rice yield prediction. So as I said, we are Angelic Lotus and we we are composed of 4 members, such as Victor, we have Teja, we have Ligin Joseph, and we have myself, CESAIRE KOUADIO. Okay, next slide. Okay, so this is the content of our work. So before diving deep into the content, I would like to first thank Climate Match Academy for this great opportunity, especially Viviana for your support. Thank you so much. It has been really helpful and we are very grateful for that support. Okay, so we will start by introduction and the background that is composed of the area of interest objective. Then we will move to the methodology, which is also composed of the climate data set, crop yield data set, and the deep learning model. So then we will read the results, the conclusion, and also the future work. So I will be presenting the introduction until the objective. Okay, so according to the FAO statistic of 2022, sorry, rice is a vital to India's food system. It contributes nearly 44% of the global rice and serving as a staple food for millions. The sector also employs more than 40% of the population, especially during rabi and kharif seasons. But unfortunately, climate change is threatening agricultural stability with erratic rainfall pattern, rising temperature, and extreme events, especially ENSO, which is the El Nino Southern Oscillation. So it's actually a change in sea surface temperature in the Pacific, as you can see on the global map here. So it has many consequences on the climate, on the weather. So we have, as consequences, we have crop failure, health issues, and mostly economic losses as it affects agriculture. It will also affect economy for sure. So we can also note that disruption causes a serious need for accurate production model to forecast yields, ensure food security, and formulate climate resilient policies. Next slide. Okay, so this is our area of interest, India, which is composed of many regions that we will present more in the other part. Next slide. Okay, so the objective of this work, the primary objective was to develop a deep learning models considering ocean indexes, climate variables in India's region, and predicted rice crop yield from Arreyndip models. So the second objective was to evaluate the production of crop yield of rice crop yield using CMIP6 scenario and possible impact over India's. As I mentioned before in the introduction, rice is is contributing a lot in India's food system. So that's why in this work, we decided to focus on rice at climate change impact rice will also impact India's production for sure. So now I'm going to give the floor to my teammate Victor to present the rest of the work. Thank you.
Hello guys, I'm Vitor. I will show you the next steps of our work. So I'll start to talk about our climate dataset. So we used the variables and the variables from the models of the coupled model intercomparison project phase 6. which is SMIP6. So we used these two models and then the ensemble means of these models, because was the best models to represent the monsoon system in India. So with that, we used the sea surface temperature to calculate the ocean indexes, which was dipole mode index, DMI, and ENSO 3.4. And also you used precipitation rate, relative humidity, soil moisture, and temperature in India's region. Um, okay, so we used these types of climate data sets for our model. And for food security dataset, we use the crop yield rice. We use these four models, which has the temporal resolution of in years, right? And it was from 1901 to 2012. Uh, okay, continuing the flow with the methodology. So first, we pick up our climate and crop model selection, data acquisition, research, and pre-processing with input and output variables, which is very important for our deep learning model. We we also did some initial statistic analysis, and then after that, we developed the machine learning model, which was actually a deep learning model, a hybrid configuration with convolution neural network and the GRU, uh, that is gated recurrent unity, which is a recurrent neural network. And after that, we apply our model with the SMIP6 future scenarios. Okay, so continuing the flow with the architecture of our deep learning model. As we can see, we splitted our data randomly. We using 80% of training, 10% of validation, 10% of testing. So we had first the climate inputs in our left. So the CNN was developed with um, four convolutions with 32 filters and a matrix with 3 per 3 in the kernel of convolution. The same for the second filter, the second convolution, the third convolution, and the fourth convolution. And in our right side, we use the ocean indexes inputs to be in the recurrent layer, GRU layer, which was 32 neurons. And after that, our two inputs go through a dense layer, which combine the CNN with GRU. And after that, it goes through the dense layer, which prepare the combination with the inputs and the weights to go to the output. So this was basically the architecture of our hybrid model. And it was that. So going and talking about the results. So we have this curve of training and validation laws over the epoch. So with that, or we conquest a loss, a mean square of 0.0007 in the validation, a MAE metric, MAE metric of 0.01, which was something like the percentile error, so it's something like 1% of error, and our score in test, which was about 0.99. So we have good metrics for our model. And in the figure behind, we have the mean of model predictions and the mean of the observed production, and then we try to see the percentage difference between what is predicted and what is observed in the test, in the test dataset. So we can see that over most part of India, their error is still something between 3% and 1%, and some regions in the Northeast, for example, have something between 6% and 3%. So we have some satisfactory error in our model. Another result that I can show to you is the difference between periods that we also calculated. So we used the SSP 585 and the SSP 245. So we also did the difference between the SSP and the historical to see the difference between these periods. So we can see that we have a loss in the production of the crop yield rice, which is very bad for us because has CESAIRE talking about crop yield in India is very important for the country and for the world. Another results we can see our trends over here and this historical trends and the SSP's trends. So we can see that surface temperature increases a lot, also precipitation rate, relative humidity, and soil moisture. But if you want to take a look in the crop yield rise over India, it is still decreasing in the two experiments. The ocean indexes, we can see that ENSO is increasing and people mood index is kind of increasing, I think. And our conclusion is that, well, first, the climate variables and the ocean index plays a crucial role in climate feedbacks and over India, and significantly impact agricultural production over India. So if you want to take a look and evaluate the deep learning model, the hybrid combination between convolution neural network and gated recurrent unit, we concluded that the model performed well because the mean absolute error, the MAE, was around 1%, sorry, and the prediction error remaining below 5% across the most part of India. Another conclusion is about the figures that I showed to you, that the model tend to overestimate rice yield in test data, but in the prediction is still we are still seeing a loss. So if we think about it, the loss probably will be more intense considering our results. Projections indicate a decline in rice productivity under both SSP 245 and 585 scenarios. And now for our study limitations. So we have a lack of validation of HMIP model outputs with observational data. And future work should incorporate higher resolution data sets, which is very important to understand better this phenomenon. Future research also should explore other major crops to better understand the broader impacts of climate change on agriculture over India. And finally, it's very important to have a systematic governance approach focusing no regret mitigation and adaptation strategies, because we have to reduce the potential social and economic impacts of declining crop yields of the climate change. So it's very important to think about that. So this is our references. And thank you. This is our presentation.